Greetings, everyone. We are here and hey, Kimmo's just about to start. Glad to have an audience as opposed to just me lying around here. Oh, yeah, Dina, that's funny too.
Hello.
Yep. Hey, Dina.
Hello.
I was just about to start my spiel, and I'm glad to not do it alone because it gets very boring talking to myself. Sure. All right. Last week I had forgotten to put the link in and Kim was here. We just talked about project stuff. I didn't tape it. So today we're going to cover the code, part of the code from last week, and the code from this week. We're going to cover a lot of stuff code wise. And then if there's time at the end, we'll go ahead and talk projects. Any questions from the previous couple weeks? No? All right. So last week we talked about joins, and we talked about the difference between inner joins and outer joins, and this union commands here. Again, the union command, all it really does, it just links two results of two separate queries that have the same number of columns in the select query. And that's all it does. It's a nice bulk processing join, but it's not very granular or savvy. I'm just going to jump down here. I'm going to just jump down to the stuff for this week here. So this week, we're going to talk about insert statements and how to make them work, and we're going to insert updates and deletes, and we're also going to talk about one of my favorite things, which is transactions, because they're incredibly important. So in order to do this, I'm going to create a table. I'm going to create a table. I'm going to call it person. I keep meaning to change this to person, not persons, because we're not supposed to do plural, but that means changing everything everywhere. And I just keep forgetting to. So we're going to have the person have a person ID. It's going to be integer, not null, auto increment, last name, bar chart 255, not null, first name, bar chart 255, and age will be int with the primary key being person ID. Drop the table if it's there. Drop the table if it's there. Was, and then create the table brand new. So when we insert into tables, the command is just insert into the table. We're doing it here. And here I've got insert into persons, and I'm valuing Williams, Venus, and 27. This is going to throw an error right away because this should throw an error right away. Yeah, it did. Because the problem is this is an auto increment, which will auto increment. But if I say insert into persons, I'm not saying what columns to enter stuff into. So when it looks at the values, the engine's going to say, hey, this table's got 4 columns in it, but you only got 3 values here. So what goes where? It doesn't know. It gets confused easy. So here I've got insert into persons, and I've got 16 Williams, Venus, and 27, which matches person ID, last name, first name, and age. And what that will do is that will start the auto increment at 16. So whatever I put here, whatever the first value in the table will be the first value in the auto increment, and we'll always go up from there. So if I run this, it'll work just fine. Okay. Now here I have this. I have the same things I was doing here, except I now have delineated the columns that are supposed to be inserted into. So it'll do a one-to-one matchup. So this last name will take Williams, first name will take Tennessee, and age will take 27. And if I run this, it'll be just fine. Here, just to prove a point, I have insert into persons, age, last name, first name. The order in the table doesn't matter. It's going to do whatever it does. Okay, it's going to look to what this tells you to insert into, and so it's going to map them that way. age 102, Williams, Willie. Okay. Now here, I'm going to do something. Here I just have individual values going in at a time. I can, however, use a select statement to do my inserts with. So if I'm trying to bulk copy over from a table into the another table, I can just write a select statement and then have that go into the other table. So here I've got select lower, and the clause lower just means this will be all lowercase. And I've got lower first name, and then all this is just a fancy way to make a random number over the number over 10. That's all that does. It's just random times 25 times 50 plus 10. It's just a fancy way. So if I run this here as a select statement, it's going to show me all this stuff. I got all these people. That's all lowercase. And then I'm going to insert this into the table. So 200 rows of an inch. So I'm going to, and I do my select statement here. Persons, I've got all these wonderful rows. So I need to talk real quick about how insert and all these statements work. There is no thing else. There is only one command in all of transact SQL that's a bulk action. Everything else goes line by line. So if I don't think I've ever talked to you about right ahead transaction logs, have I? Are y'all familiar with them? All right, this is fun. I love this. So, okay. So here we have our computer with our desktop computer that we're sitting at. Okay. And then over here we have our server. Trying to be all fancy here. There's our database. Eraser. All right. Now, one would think that when a laptop or a customer writes to the database, it writes directly to the database. So any change it makes it to the database directly. And that kind of makes sense. However, if I'm adding 20 lines to the database, okay, they don't go in as 20 lines. They go in as one line at a time. I refer to it as RBAR, row by agonizing row. So like insert one line, insert one line, insert one line, insert one line, insert one line. Okay. So with that, if I'm inserting directly into my database from my laptop computer, for some reason my connection breaks, the database has no idea where things have stopped, where things began, whether I completed my transactions or not. So we now have a corrupted database, or what they refer to as suspect, because we don't know that we have clean data. Okay. So what we need to do here, instead of doing it this way, there is this interesting thing that all database engines do. And they have something called the T-log, or the transaction log. Okay, or the T-log. So what happens is this T-log exists on a drive somewhere else. It usually exists on a very, very fast hard drive, usually an SSD, that can do a lot of read and write. There's a term called IOPS, input output per second, that is very, very high. So when the user writes to the database, it doesn't write directly to the database. It writes to the transaction log. Okay, it writes the transaction log first, and then from the transaction log to the data. So what happens is I'm inputting 5,000 rows from my computer to the database. It starts writing here. So what happens is I send the insert statement over. It says I'm inserting to this table. Immediately, the transaction log now has an empty copy of the schema of that table in it. That's the first thing that it does. Pulls that into ring. Okay. And so then it starts inserting the rows one at a time into that table and transaction. So it's doing one at a time into that transaction line right. So it's not ready to here, and it's not ready, it's ready to here. Now, what that means is this database is protected from anything going wrong at the moment. Okay. So if I'm inserting into the person table and someone comes along and makes a select on the person table, they're going to get clean data because nothing's been added. It's all sitting over here. Okay. Making sense? Okay. So this continues writing, this continues writing, this continues writing until it reaches what they refer to as the buffer. Once it says, so the buffer is usually about 20% of the available RAM. So once that's full, it then starts writing to the database. Okay. So the stuff that's here, this starts getting written to the database like this. Now, the database in the database has a log in it, so we know it's going there. And they have what's called an LSN. Last serial number. Okay. And so the database in the table has an LSN for the last thing entered into that table. And every time a new entry is into that table, it gets an LSN with it. The LSN matches over in the transaction log. So everything here has an LSN. So when the LSN goes from here to here, it keeps track of it, right? So I'm in 20,000 rows. I lose connection. And the power dies. Okay. Whatever is here is going to continue to. So what's going to happen? It's going to everything. The database goes down. The database powers out, shuts down, done. Okay. We reboot it. It comes back up. The first thing the database does in its boot up procedure when it pulls the database up, it says, "Hang on, my last LSN was like 512." Okay. Then it looks to the transaction log and says, "Hey, what was your last LSN?" And it says mine was like 712. Okay. And then it says, "Hey, you were obviously in the middle of something. Do you have all the data that you were supposed to put into me from the query from the customer?" And so when this query came over here, it said that it will be 5,000 rows, right? So it knows that its last LSN should be whatever it is. So let's say for sake of argument, it died within the last 200 rows. Okay. So when it comes back up, the database goes, "Hey, transaction log, what's your last LSN?" Well, it's 712. Do you have the complete transaction? And I'll say, by chance, I do. So it will copy the rest of the data over here and then complete that transaction and be done with it. If it does not, if it comes up and says, "Hey, we're at 512, what are you at? I'm at 712. Did you complete the transaction?" No, we did not. It's going to go back to 511 or wherever it started. Okay. So there is a built-in self-healing to a transactional database that ensures a power outage will not corrupt the data. And it's important to remember this because this transaction log becomes key. Okay. Now I said that when it comes over here, okay, it creates a table based on the table from it. It's not a table called person. Depending on the transaction that's happening, it's one of three tables. It's a table called inserted, a table called updated, or a table called deleted. Okay. So if I'm inserting data into a table, it will create a table and a temporary table called inserted. It'll give it the schema of the table it's being inserted into. It will insert the data into the inserted table and then send it over to the actual database, the correct table, and then it'll delete that temporary table. Updated actually doesn't create a table, but what happens is it creates an inserted and deleted table. Because an update is an insertion and a deletion at the same time. If I'm updating 1,000 rows and changing the zip code from 32828 to 90210, the transaction is going into that and deleting that value from the table and then inserting a new one. So the way the transaction log tracks it is it creates the schema of the table being updated. It's creating two versions, one that has the deleted information, one that has the insert information, and then puts that over there. And the deleted table actually obviously captures all the deleted stuff and puts it into that table and then deletes it. Now you've asked yourself, why would I want to put stuff into a deleted table before I deleted it from the thing? First of all, I want to make sure that the data that's in the deleted statement is correct and it's looking the correct way and it's formatted the correct way for the schema. But everything that is done here is recorded in the transaction. Just because it goes from here into the database doesn't mean it's erased. It's recorded. So you can, if you have a database failure at 2 o'clock in the afternoon and you want to restore your data, but you had your backup was at noon, you can actually restore your database up until noon, and then use the transaction logs to bring you to the exact moment your database went down. None of this is talked about in this course. I just find this very interesting. And I know, right? You think it would be. But it's going to make a point for what I'm about to show you. Okay. So here, now I'm going to update the persons. I'm going to say here, I'm updating persons. I'm going to set the first name equal to upper first name, where age is between 12 and 25. And then I've got another one here. I'm updating persons. I'm joining customer with persons on the last name. And then I'm going to set the age to 1999, where the last name persons and the last name of customers are the same. So here I'm going to run this, and I get 56 rows. So if I run my selected persons, I'll see some of them here are uppercase on the last name. And then if I go here and I run this one, I have 47 rows. And if I look from here, I got some that are age 99, 99. So when I update tables, I can either do it just straight like this, saying update the persons to set this column to this column where the age is, or I can do on inner joins. Then I've so okay, so back for inserts real quick. I can also do I just got this one here. I can do inserts this way too. I can do inserts into persons, and then I can do values and then do like 1, 2, 3, as many as I want there. So I don't have to write insert into persons values, insert that whole thing. I need to merge these two queries here. So I can do that too. So the last thing here is I'm going to go ahead and delete from persons where last name is like the letter F. Now, when I run this, it goes through the entire table, one row at a time, comparing both tables, finding where the last names match, and then changing the age. So it literally goes row 1, row 2, 3, row 4, row 5, row 6, row 7. That's just the nature of how it does it. If I have a where clause in here, it limits it, but every time it goes to the final update process, it's always going one row at a time because each row of change is logged in the transaction log. Here, I'm deleting from persons where last name is like F. When I run this, and I deleted 2 rows, not a whole lot of rows, it went through the entire table and go, no, 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 yes, no, 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 yes. Indexes on tables do make a difference when it comes to it's faster. It'll go down to where that part of the index is. However, if the table is less than, I think it's 200,000 rows, indexes don't count. It'll always be a full table scan in tables less than 200,000 rows. Here I have delete from persons, inner join customer on persons. So here I'm deleting from the persons table, I'm joining the customer table, and deleting the last name of person and customers match. And if I run this, I delete 51 rows. And again, it's gone one at a time. Okay. So let me jump down. Any questions on that? Do you all understand the process of insert updates, deletes, how they work, the transactional, like just bonus knowledge, stuff like that? So you might ask yourself, how do I make sure I'm not screwing something up royally in my insert statement? How do I know that I'm not running this and like, oops, I've destroyed everything in the table? Now, I used to work for a company called Property Insight. I was deleting stuff from my table and I accidentally deleted a table in a production database that was critical for everything. We were down for about an hour and a half while I restored it. My boss stood over me the entire time. It was very unsettling. So there's that. Okay. One thing I forgot to talk about. Alter table, person, add, email, varchar. I'm going to do this varchar. Okay. So now when I've added a column to the table. Okay. Now, just a real quick sidebar on database design. When we are designing our databases and we're setting up that initial schema, we want to make sure we're doing it in such a way that we do not add tables later on. We don't want to add tables. We want to add columns, add data, but we don't add tables. Because when you add a table, it dramatically changes the entire schema and how it works. For example, if I had a database, and I've seen a bunch of people do this. Okay. So if I had a table and that table was shoes, right? And I want to do brands of shoes. I wouldn't create a table called Nike, and a table called Adidas, and a table called Reebok, and a table called this, right? Because if I did this, then if I added a new brand of shoe, I'd have to add a new table, and that changes the entire flow of data. So what I would do instead is I would have one table called brands. And under there, I'd have brand ID and the name of all the brands. That way, if I added a brand, I just add a column, a row of data in the table. Inevitably, one or two people every semester when they're making tables do this. And it is exactly what people who start designing databases do. You think I need a table for each specific brand? No, you want one table for a brand. So and you don't want to have to add columns. You want to make sure you're right, but inevitably the world changes and you have to add columns that you never thought of before. So if I were designing a database in and because they were around, AS400s were around since the mid 80s. So if I was going to design a customer database in like 1985, I wouldn't have cell phone number and I wouldn't have email address because those didn't exist back then. But as life went on, if my business, a great company like any large car manufacturer still uses the database they used back in the 70s and 80s. They've just added on over time. Whenever you go into a business and you see their screen is that green monitor and everything is like a dot matrix on the screen and there's no mouse involved, you're just using it like using another one as that Advanced Auto Parts, another one. That means that database has been around for a long time. And so when they made those databases, email didn't exist. Cell phones, they had to go back and add in there and add a column to it. So adding columns is totally fine. Okay. So here, this way I add a column, I add persons there. And now to populate that column, I'm going to go here and I've got update persons. I'm going to set email. I'm concatenating the first and last name. I'm taking the first 4 letters of the first name and the first 4 letters of the last name with an underbar and adding gmail.com. And I run that update statement. And now when I look at my selected persons, which is up here somewhere, I now have all these wrong email addresses. But what I can do here is another command I can use, which is replace. So the replace command, you take the string you're using, the part that you want to replace, and what you want to replace it with. And then you just run that. And now when I look at my tables, I don't want to do that yet, thank you very much. Now they're all correct. Okay. Now, back to what I was saying before. How do I make sure that I don't break everything in trying to do something? I have this command called start transaction. What this does is it begins in the data, it opens the transaction, and it does not close it until I explicitly tell it to close. When I run something like this, it's a transaction. And it implicitly opens and it implicitly closes because anything that I've highlighted is the transaction. And it runs and then it opens the transaction database and then closes the transaction. When I run start transaction like that, it opens the database. It sets the transaction log and it says, do not complete this transaction until I tell you to stop it. So I can go here and I can update persons and change the age to 990. I changed to 75 and do this. Nothing changed. I'll just do this. So, and all of a sudden, and I go here and I select from persons. I'm like, oh, geez, I screwed up. I destroyed the database. But because I'm in this transaction here, I can choose rollback. It sets everything back. And it's back the way it was. Because each row was reported in the transaction log, when I say roll back, it looks at the transaction log and just sends everything backwards to the way it was before I ran the initial transaction. If I do the same thing here and I just hit start transaction and I do update age 75 and I have effect on empty rows and I hit commit, well, it's that way forever because I forced it to stay at 75. Now, remember I said every command we run is line by line, except for one, except for truncate. Truncate is a mass deletion. If you say truncate table and name the table, it empties that table out and there is no bringing it back. Okay, so here I've committed that transaction. Everything looks good. I'm going to go ahead and start a transaction. I'm going to select the persons. It's still there. I'm going to truncate table persons. It is now empty and I'm going to roll it back. And I'm going to do the search and it is gone forever. Truncate is a flushing command. It is the only such command in all of TransactC. It is best never to use it because it is the one thing you can't come back from. Because if you look in the transaction log, and there's really no way to do this equal, at my delete statements, you will see those delete statements go 1, 2, 3, and you'll see them count out. But when you look at truncate table, all you will see is the command truncate table, and there'll be nothing else there. Okay. So the gist of the conversation tonight is how updates, inserts, deletes work, how you can use them with joins and things along those lines. How truncate is a terminal function. There's no coming back from it. You can use a delete with an inner join like here. I think I showed you that before. And it's important, again, the key to remember is when you're doing a delete like this, it's every row one at a time. Boom, 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 boom. R bar. And then truncate kills everything. I don't think transactional stuff is in your course. I think I just add that for fun. I'm pretty sure. Was that?
I just said thanks. I appreciate it.
Oh no, transactions are clear. And then so next week, the last thing we talk about next week is case statement. And case statement is super fun. But we'll talk about those next week. So yeah, so that's the code for this week. That's just what you need to know going into this week. At this point in time, next week's the last week. We'll talk about code. Weeks 8 and 9, we'll talk about strictly database design, answering questions about your final projects. And then after week 9, we don't do Tuesday nights anymore, except on demand. If you need me, I'll come. If not, I'm gonna be doing something else. So, and also, as always, if you need to meet during the week, I work on this computer over here. All I gotta do is turn around to this computer over here. So if you guys text me and say, can we meet for half an hour? I can usually break away from what I'm doing and open up this. And I haven't done it in a while, but I'm going to try during week 12 just to leave the Zoom on for like a day. And then you can pop in and ask questions. Like have like office hours, like open office hours virtually. So I'm not going to talk database design tonight unless you got specific questions. I'm not going to build a database this week because I can't sit in this chair for more than 35 to 40 minutes. And I'm getting on that. I've got a timer going off here in a second to say get up and move around or bad things will happen to you. So, Kim, do you guys have any questions?
Nope.
Okay. I think you're both doing final project. You're doing good on it?
I started working on it tonight and I actually created another table like you were saying it when I was making one, I was like, hey, I think I need this. So it just kind of branched from that naturally. So that was good. But
And we talked last week pretty extensively, so I look forward to seeing what you're doing. And Dina, how are you doing on your project?
I'm kind of not sure where I need to end up, but
Uh-huh.
I'm doing pretty good. I've already created all the tables and I've got data to populate in them. I've got relationships and such. But I'm kind of like not sure where to find like all the details of where we need to land. I mean, I can make all of the update stuff and things.
Let me do that right now because I think I may have forgotten to do that with everything else going on in my life. So what you need to turn in, where you need to land, what are the deliverables?
What are the what?
The deliverables. What do you have to give to me for the grade?
Yeah.
So I need the ERD of your database. That is just the design. When you look, I don't want the everyone. Someone inevitably sends me the WMD. I don't want that. I can't do anything with it. The ERD is just when you look at over here.
Yeah, I've got an ERD built.
So I need you send me that.
Uh-huh.
Okay. I need, and that ERD. So that ERD will have. Okay, so I'll have ERD. I need the code to create the database.
Yeah.
Okay. And that's easy, just forward engineering. And then I need code to populate the database. Oh, For the ERD, I only expect you to have between 8 and 10 tables.
I think it said 12
Yeah.
plus, which I've already done. I think I have 15 or
Yep,
something.
that's fine. That's my fault because I don't that the criteria they have for the final project is not what I use. That criteria is made 4 or 5 years ago, and I just finally got permission to update it. So this will be the last time you'll see that there. You probably won't ever see it again because you're not going to update the class again. But if you've done over 10, that's totally fine. I usually tell people to stop at 10. And everything I tell you from this point on is going to make your life easy if you're following what it said there. And the code to pop the database, then I need 4 to 6 case studies. And what those are is, let's say that you were doing a database on your baseball card collection, right? So you've created the table, you've created the data that's inside it, and then I want to see 4 to 5 queries that you write that tell me how people would use that data, like you assume that. So like, show me all the teams that Reggie Jackson's played for. Show me all the cards that I have that are worth over $15. Show me the last 15 cards I put into my collection. Show me what teams I have the most. Show me all the teams and how many cards of each team I have. Things like that. So I just want to see, show me how the data is used. The thing that you look online asking for all these CRUD statements and all that other stuff, I don't care about because these are CRUD statements. We're switching the focus on how this assignment works away from. It's like letter of law versus spirit of law stuff, right? The letter of the law is just do it this way. I don't care about that. I want to see if you understand how databases are used by people, right? And then I need a PowerPoint presentation or 5-minute video explaining to me your project. What the
Do
data.
you have like an email with all of this?
I'm going to put it in the announcement, and I should have sent this out 2 weeks ago, which is when I had my surgery. So I'll use that as my excuse for now. But I will send that out now. With this announcement, I'll put into the announcement for this tape, this thing, and I'll send an email out with that. Okay. I do apologize for not getting this out 2 weeks sooner, but so PowerPoint presentation or my video, just talking about the project. And then the last thing, and this is optional, because I never understood this thing, but people like to do it. A mock-up of the application that consumes the data. So you would, and I don't care how it doesn't need to be coded. It could be like in Paint, in Word, and you can get some markers and crayons, and you can use your Cricut to do it. I don't care how you do it. Just like say, here's the page of the application that I envision, and here's the search box in the player's name. Here's the button that's going to do that, and then this search box will link back to the player's table, and then this is the results window that's going to result from this query coming in. You kind of understand what I'm looking for there?
Yeah, and you're saying that part's optional though, but
We don't do
just
it.
kind of have an idea.
Yeah. It's funny because this is in the thing, but if you look at the rubric, all the rubric cares is about the CRUD statements, which is the case studies, the ERD being normalized properly, and one other thing. So all the other things are just kind of there.
So I imagine that you want our case studies to do each of the CRUD statements.
No.
No, not necessarily.
All I want the CRUD statement, all I want the case studies. CRUD statements are very easy to write. I mean, they're insert, updates, deletes. They're not they're not,
Not like joins and other things necessarily, which
there's
is
nothing
more.
interesting about them. They're just like, they're digging a hole, right?
Yeah.
I want to know that you guys know how to look at that database and make it sync. Make
Yeah.
get that data out and show me. Give me CRUD statements are like breathing and heartbeat. I want like singing and dance. I want you to say, here's how this data would be used.
Hmm.
So and if you want to say if you want to do a case study saying I need to write a query that increases the cost of my baseball cards by 20% or by X% when
Hmm.
it changes, that's a valid use case. They don't all have to be select. You can give me 5 select statements showing me how you would like how someone would come in and use that data, right? Because not all databases that we give to people are writing. You can write to them. Some of them are just selects. They're just read only.
Yeah.
Right? So it's how you envision this really is a database that you envision how you want it to be and how you design it out and how you think that data should be utilized by the people who access it. And that for me is the most important thing. And there are 3 of us reworking this, so we're kind of having conversations about that because a lot of people are very technical and want that other CRUD stuff, and so we got to find a way to um, make it interesting. Um, uh, but yeah, for the purposes of my class and my final project, those case studies are just show me that you know how to use the data.
Okay.
And I
I mean, 4 or 5 case studies, that's not even a lot. So,
not no, I try to I don't want this project to be overwhelming. I want it to be interesting. I want you to spend time on the design process to enjoy and see. I'm going to get all philosophical here. So there is a beauty to database. There's
I'm with you.
I love it, and I want people when they're done with this project to go, you know what? That was fulfilling. That was something I made that was beautiful. Um,
Mhm.
like if you were looking at painting. So you're on the point. So you understand where I'm coming. Yeah. So this is all I need from you.
Yeah, I thought you were gonna want a final produced product, like,
No.
here's my PDF that this will output,
Oh, and so here's and I don't want the ERD. I'm gonna put this here.
You are.
Not do not put in PowerPoint or video.
Do not put what in PowerPoint or video.
ERD.
Okay.
So because when inevitably someone will put the ERD in the video, and I've got to pause it and then take a screenshot and explode it out so I can see it because I got 55-year-old eyes, so I can't see these little tiny words on the screen. And then they'll put it in the PowerPoint presentation. It's the same thing. I got to find a way to explode it out so I can actually see it. So the ERD should be a separate file. I
Got
should
it.
1, 2, 3, 4, 5, up to 6 separate files.
You want, like, I know you could do the create the database and populate the database
I
in
want
the same build.
I want them separate because I want to when I grade it, I want to run the create database and I want to look at that code. I want to see if it works because if it doesn't work, I want to go back and play with it, see why it doesn't. There should be no reason that it doesn't work because you should have forward engineered it. Um,
Sure.
I want to code the database. I want the code to populate the database. I want that separate so I can run it on its own. And I want the case.
Okay.
Now, if you put it into one file and clearly demark it where like here's where this begins and here's where this begins, that's fine. But
Yeah.
people just send me like three notebook pages where all the codes in there. I got to go separate myself.
Uh,
So I like it in separate files. It just makes it easier for me to look at. And if you've already cast the code to populate the database, that's cool. For anyone who is watching this at home and did not do this yet, I always recommend writing the case studies first and then populating the database because you don't need to put in like 800 lines of data into the database. All I need is enough that I'm getting results from these queries.
mhm.
If you're writing a card on baseball, if your case study for the the thing is like show me all the teams that Reggie Jackson's played on. Make sure Reggie Jackson's a player, and he's got 2 or 3 teams that he played on, whether they're real or not, I don't care. In the table, so I get a result when I run the query. I don't need 1,000 results. I need 5 or 6 results when you run a query. When I run a query to make sure it's working the way the logic's working the way it should.
Mhm.
Yep. So yeah, and this should have gone to you guys 2 weeks ago. So I'll put that in with the announcement when I post the video today or tomorrow morning. Did that answer your question on that? It should be a lot easier compared to what's in that thing in week 3. Kim, you good with that?
Yeah, I'm excited.
Cool. Cool. Well,
I'm good.
Cool,
I
cool.
think that's fast. So yeah.
Well,
It's a lot easier. I appreciate that actually.
well, here's the thing for you guys, because you have such a database, it's pretty fast. For people who come in here and they've never done this before, they're sweating this in week 12 trying to figure out how to do it.
Oh,
So
Okay.
I have all skill levels here, so I'm trying to kind of mid-range it. And I found that the people who know databases well look at this and take the opportunity to like really flesh all this stuff out. And I get I really love good case studies. I love to see the more complicated the case study is. Throw me a couple of inner joins in there. Show me something like really, really complicated. That's a great.
mhm.
Mhm.
This project should be match the skill of the person trying to do it. This is good for
Yeah.
people who've never done it before, and this is good for
I
someone
don't think I don't think I could live with doing a simple one because I already have a big idea. So
totally fine. And I
That's
totally
cool.
and I look forward to grading because it's fun for me to grade this. And that's kind of as we redesign the course, I'm trying to make sure it stays fun.
Yeah.
Because databases can be very, very good. And I think they can be very. Anyway, I am past my 35-minute mark. I need to go stretch my knee. Thank you
Yep.
guys for tonight. I appreciate it. If you have any questions, hit me up during the week, text me, email me. If not, I'll see you guys next week.
yeah,
Okay,
if you'll
thank
copy
you.
that last section into a chat or something, or your email, that'd be
Well,
awesome.
I'll drop it in the chat. Drop it in the chat.
Perfect.
Yep.
Thank you.
Sounds good. Good night.
Appreciate it.